Hey guys, and welcome to the Amity Algebra Academy. I'm Maya.
I'm Samantha.
And I'm Joe.
And today we will be teaching you how to solve exponential equations with a common base. Our objectives for today are to find the lowest common base between two or more numbers, to use the properties of exponents to simplify these equations, and lastly, to solve these exponential equations with a common base.
So a quick review. What exactly is an exponential equation? An exponential equation is one in which the variable exists in the exponent. For solving an equation with a common base, you make sure both sides have the common base and then use the following property to solve. If b to the x equals b to the y, then x equals y. Now, if you're not familiar with exponential equations, you may want to watch another video on this channel just specifically on what an exponential equation is.
Okay, so now here we have our first problem. So the problem I'll be going over is 8 equals 2 to the x. So the first thing you want to do is you want to find a common base. So we can see here that the common base is 2. So 8 can be simplified to 2 to the third, and then that is equal to 2 to the x. So using properties of equality, we can see that we can set the exponents equal to each other. So 3 equals x. So now we have a solution here where x is a value. So we want to go in and substitute this back into our equation to make sure that it's true. So 2 to the third equals 8, and so 8 equals 8. So now that we see that we have an equal equation here, we can see that this solution makes the equation true.
So the next problem that we will be doing today is a little bit more complicated. In this problem, you'll have to find the common base and then simplify the exponents and then set the exponents equal to each other. To get started, we can easily see that 9 and 729 have a common base of 3. Be careful because they also have a common base of 9, but you want to choose the lowest common base. So if we use the common base of 3, then you get 3 squared raised to the 2x equals 3 to the 6th. Then we have to use properties of exponents to simplify this equation. So using properties, we would get 3 to the 4x equals 3 to the 6th. Now that we have a simplified common base, we can set the exponents equal to each other to get 4x equals 6. Next, you want to divide both sides by 4 and then simplify the fraction. So the solution to this problem would be x equals 3 over 2.
Okay, so this next problem is a little more challenging. Our first step is to find the common base between 8 and 1 over 16. So our common base is going to be 2. So we can simplify this to 2 cubed to the negative x plus 2 equals 2 to the negative 4 raised to the 2x plus 1. Now by our properties of exponents, we can simplify this to become 2 to the negative 3x plus 6 equals 2 to the negative 8x minus 4. Our last step is going to be to set these two equal to each other due to the property defined in the beginning of this video. 3x plus 6 equals negative 8x minus 4. Lastly, we're going to move the 3x to this side and the 4 to this side to get 10 equals negative 5x, and divide by negative 5 to get x equals negative 2.
Alright, so to wrap up this video, we want to just go over the steps for solving an equation using common base. So your first step is to find a common base. You want to make sure you find a common base so that when you find a solution, it's correct. So the next step is to simplify your exponents. You need to simplify your exponents correctly, otherwise your answer is not going to be right. So then you want to set your exponents equal to each other so that way you know that it's equal and that when you go to solve for your variable, you're doing everything correct. So then you solve for your variable, and then once you get your solution, you want to check your solutions, because the worst part is when you get a solution, but it's not right. So you always want to go back and check your solutions. If you have any other math troubles, make sure you check out the other videos on Amity Algebra Academy. I'm Joe, and thanks for watching.